Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have studied about what are the rules of IUPAC nomenclature for alkynes, and that is the reason that we are going to apply on the few examples, that is on the few structures, and we are going to predict that what would be the basically IUPAC nomenclature of that alkynes. So let us do that. So starting with the first one, that is the most simplest one. I think you are able to predict this one, but let me go through this with the IUPAC nomenclature, the rules of IUPAC nomenclature, and then we'll name it. So this is the structure that we have, and we have to give the IUPAC nomenclature, but we have to set the longest chain. We also it doesn't consist of any branching, and even this is the one which consists of the carbon-carbon triple bond, so we could easily say that this one would be the longest chain. So the first thing has been done, that is the longest chain selection has been done, and what we have to do is the second thing is to give number. But the number can be given from either side, that is from this side also as well as this side also, but we have to give the number from which side. That is the main thing, and that is the main priority that we have to give. So suppose if I give the number from this side, so therefore this would be the first carbon atom, this one would be the second, this is the third, and this would be the fourth. And what if I give the number from this side, that is this one would be the first, this one would be the second, this is third, and this is fourth. So basically this is a symmetrical molecule, and from either side, suppose if any of the sides, suppose if we have given the number 2 is the one that we are getting from both the sides. That is, it indicates that the carbon-carbon triple bond starts from the carbon number 2. So that's the reason we could number it from anywhere. So therefore, let me number it from here. That is 1, 2, 3, 4. So now, because the total number of carbon in the straight chain has been found to be 4, therefore it indicates that in terms of an alkane, it is basically butane, and in terms of an alkyne, it would be butane. But what is the position of carbon-carbon triple bond? That is also the main thing. So here we have got to know that the position of the carbon-carbon double bond is from carbon number 2. So that is the reason the name of this would be but 2-ine. So but 2-ine. So this is what we gave the name to this structure that we have. And now let us move on to the next one. And we are going to do the different kinds of nomenclature, and we are not going to use the similar kind of thing. We are going to try the different kind of one which will have the position isomer as we have indicated in that is in alkenes or similar to that in alkanes also. So let's talk about this thing. So again, this is the one. This is not symmetrical alkyne, and we know that this one would be this longest chain that we consider. So the numbering, yes, the numbering is the main concern, and it can be started from the left to right or right to left. But which one would be the priority, and which one is the one which is following the IUPAC nomenclature rule? And that is the one that is the carbon-carbon triple bond, which is being very nearer to an end. So if I number it from here, suppose this one would be considered to be the first carbon atom, this would be the second, this would be the third. I would write over here as just for an option thing, and this one would be the fourth and fifth if we number it from left to right. And what if we have numbered from right to left over this thing? So therefore this one will be the first carbon atom, this one will be the second carbon atom, third, fourth and fifth, making this number to get a least number compared to that of the previous one, that is this one. So that is the reason the correct method to name this one is numbering from this side, that is from right to left. So therefore this will be the first, second, third, fourth and fifth carbon atom. And here the carbon-carbon triple bond starts from carbon number 2. Therefore we have got the position of the carbon-carbon triple bond, and meanwhile while talking about the number of carbon atoms that it has 5 carbon atoms. So in terms of an alkane, it is been called as pentane. But this is not pentane, this is pentyne, and moreover the thing that is the carbon-carbon triple bond is present at carbon number 2, making this to be called as pent 2-ine. So pentyne, or basically pent 2-ine. So it's an easy one that we have done. And now let us move on to the next one. That is this one. So for this, what we have to do is we have to select the longest chain that should consist of carbon-carbon triple bond. So either I could select this one as the longest chain, as you could see over here, or either I could select this one as the longest chain. So this is the longest chain that we have, and that consists of basically carbon-carbon triple bond, and making this to be known as basically an alkyne. but the numbering will start from which end? That is the main thing. So in terms of, suppose if this would have been an alkane, then the number would have started from that end where we could have received a branching nearer to that end. So suppose if this would have been an alkane, then the numbering would have been started from here, that is 1, 2, 3, 4. But IUPAC nomenclature of or the rules of IUPAC nomenclature of alkyne states that we have to number from that end where we could get the multiple bond very nearer to that end. So in this case, the carbon-carbon triple bond is the multiple bond that I am observing over here. So therefore, in this case, the branching is not the main concern. The main concern is about the carbon-carbon triple bond or the carbon-carbon double bond, or we could say as carbon-carbon multiple bond. So that's the reason we have to number it from that end where we could get less number to the, or where could be give less number to the carbon-carbon triple bond. So that's the reason we will number this as carbon number 1, 2, 3, and 4. So this is the one that we have got, and in this case basically the third one, that is the third carbon atom, is being attached with the methyl group and making this to be called as a group having methyl, and that is on the third position. So therefore, whenever we write the IUPAC nomenclature, whether it would be alkane, alkene or alkyne, we always write the group or the substrate first, and then we move on to the parent alkane, alkene or alkyne. So similarly here also we could see that this methyl group is been attached on the third carbon atom. So therefore we could easily write that it is 3 methyl. And the total number of carbon that has been present in the straight chain is basically here is 4, making to be this called as butane in terms of an alkane. But this is not alkane, this is alkyne. And even the carbon-carbon triple bond, it starts from carbon number 1. So therefore the name of this would be, can be written as 3 methyl but 1. Very simple. So this is the another type that we have did, and we are going to do the another one that is of another type. So let us see that how can we solve the other one. But yes, these are the different kind of thing that we are going to observe. So let us move on with the fourth one. Again, this one that we have, and for which we have to select the longest chain, and always the first rule has been obeyed, and we have to select the longest chain. So you might be thinking that the longest chain is up till from here to here, which consists of carbon-carbon single bond, or having at least carbon-carbon triple bond. So is this the only carbon-carbon longest chain that we have? No. This is the longest carbon-carbon chain, because it is 1, 2, 3, 4, 5, 6. So this is how what we have got, and we have selected the longest chain. And the next thing that we have to do is numbering. Yes, now we should not concern with the branch one, and we should always concern with that is the multiple bond that we could get from any particular end. So therefore the numbering should be done from that end where we could get the carbon-carbon triple bond or carbon-carbon multiple bond to get a very least number. So therefore the numbering will start from here. Because if I number it from here, that is it would be the first, second, third, and third one. And moreover, if I will start from here, that is it will again be started from 1, 2, and 3rd. So in both the cases, it is been equidistant. But why I have selected this one? Because I could see that the branching is very much near to that. So even though if I am applying a rule of alkyne, I have to also apply the rule of alkane. That is the one which from where we could get less number to the branching one. So that's the reason we have selected here from this carbon, that is it is the first, second, third, fourth, fifth, sixth. And in this case basically I could see that the methyl group is the one which is attached to the second carbon atom of the straight chain, what we have chosen. And in this case so we could write it as 2 methyl. So 2 methyl, and the total number of carbon atom in the straight chain has been found to be 6. So in terms of an alkane, it has been found to be, or it is can be said to be as hexane. But this is not an alkane, this is an alkyne. And the carbon-carbon triple bond, it starts from carbon number 3. So therefore making this to be called as, that is 2 methyl hex. This is the 3 which represents the position of the carbon-carbon triple bond, and ultimately is an alkyne, and we know that alkyne are being substituted by the alkane from where the AN has been replaced by YME. So therefore this is an hexane in terms of an alkane, Now it is, because of that carbon-carbon triple bond, it is hexane. So this is how we have given the name for this fourth one, and we have another example also, and that is also we are going to observe. So let us move on with another example. That is the example number 5th. That is this one. And here what we have to do is, again the rule is very simple, and even this is a very simple alkene. And the thing that we have to do is we have to select the longest chain. So this is the longest chain that we have, because it doesn't have any kind of branching and all. And the main thing is, yes, numbering. We have to number from which end? From that end where we could get a less number to the multiple bond. So even though if I select it from here, suppose, so this is one which would be called to be carbon number 1. This would be carbon number 2. So I could see that at carbon number 2, a triple bond is being, I could observe carbon number 3, carbon number 4, carbon number 5. So making it known as 2, 5. But what if I have numbered from this? That is, this one could be called as carbon number 1. I will write over here. Carbon number 2, carbon number 3, carbon number 4. So now here what we have got is carbon number 1 where we could receive the carbon-carbon triple bond, and carbon number 4 where we could get carbon-carbon triple bond. So therefore this is the better one that where we could name it, and that's the reason the name of this one would be starting from that end. That is the numbering would start from this end, that is carbon number 1, 2, 3, 4, 5 and 6. So in this case basically it consists of 6 carbon atoms, making this to be called as an hexane in terms of an alkane. But this is not hexane, this is hexane. So therefore the carbon-carbon triple bond is being observed at carbon number 1 and carbon number 4. So basically there are 2 carbon-carbon triple bonds, making this to be called as hexa. And the total number of, and the carbon-carbon triple bond, it starts from carbon number 1 and carbon number 4, making this to be called as hexa 1, 4, which is the position of the carbon-carbon triple bond, and that there are basically 2 carbon-carbon triple bonds. So that's the reason the name of this would be dianes. Very simple to understand. So this one was the first example where we could see more than 2 carbon-carbon triple bonds, or more than 1 carbon-carbon triple bond. So now let us move on to the next one. That is we have, that is this one. So this is the one that we have, and we have to select the longest chain, and so this is the longest chain that we have, and the first thing is we have to number it, and the numbering is the main challenging thing. So talking about, because this is an alkyne, we should number it from that end where we could receive first or less carbon-carbon triple bond. So, but this is not only it has carbon-carbon triple bond, we could see that it has carbon-carbon double bond also. And that carbon-carbon double bond is not equidistant from both the end. Because if I started from this end, so therefore this is the first end or first carbon atom from where we could receive or where we could get the first multiple bond, and this is the rule of the IUPAC nomenclature of alkyne. So that's the reason, even though it is the parent chain is basically an alkyne, or the parent, the name of this hydrocarbon would be an alkyne, but the numbering will not start from that end where we could get carbon-carbon triple bond. But here, because of the carbon-carbon multiple bond that we have observing from that end, that is from this end, and which is carbon-carbon double bond, that's the reason we have to number it from there. So therefore this one will be the carbon number 1, 2, 3, 4, 5. So we see there are 5 carbon atoms here, so we're making this to be called as pentane in terms of an alkane. But this is basically an enine that we have studied in the rules of IUPAC nomenclature. And because of double bond is also been present, making it to be named as ene, while this is carbon-carbon triple bond, making that to be named as wine, basically YNE. And the name of this would be in this manner, where we could receive that there is basically 5 carbon atoms, making this to be called as pent. But the carbon-carbon double bond is at first position, so therefore we could write it as 1 ene. This ene represents carbon-carbon double bond, and this one represents the position of the carbon-carbon double bond. And the next is we can see the carbon-carbon triple bond at position number 3. So this position number 3 will end with YNE. The name will end with YNE. So that makes this YNE, that is, it is basically an carbon-carbon triple bond, or it is basically an alkyne which consists of carbon-carbon double bond also. So this is what we have did, and this is a type of another example that we have did, and let us move on with another one, that is this one. So now, yes, the first thing is we have to do is we have to select the longest chain. So again, this is the longest chain that we have, and talking about the numbering. So the previous one that we have did, we have numbered it from this end, and there was a reason that we have numbered it from left to right, and the reason was because the double bond was present over here, and the rule was very simple that we should number it from that end where we would get the first or nearest multiple bond we could get from that end. So that is the reason we had numbered it from here. But if we observe this one, so this is the one where we could get carbon-carbon triple bond, which is very nearer to this end. So, and even the carbon-carbon triple bond is called to be a multiple bond. So therefore, we will number it from this end. That is this one with the carbon number 1, 2, 3, 4, 5. But while naming, it is basically an alkyne. So therefore, the alkyne should have an basically parent name, and we can't give the name of ene as a parent name because it is not an specifically an alkene. It is basically enine, and enine has an end of yme. So making this to be called, making priority to be named as a that is parent name to be called as enine. So therefore, how can we name it? It would be very much easy because the total number of carbon in this case is basically 5, making this to be called as pentane in terms of an alkane. But because it is an enine, so therefore we will name it as pent. At the position of the double bond should be present earlier, and that's the reason we could see that at position number 3 we could get the carbon-carbon double bond, that is pent 3 ene, and at position number 1 we could receive carbon-carbon that is triple bond, that is pent ene 1 I. So this is the name of the one that is on your screen. So now let us move on to the next one and the last one, that the last kind of IUPAC nomenclature that we are going to do, and this is the one that we are going to do, and a very huge one, but let us name that also. So selecting the longest chain, again this one would be the longest chain because it doesn't consist of any kind of branching, and numbering. Yes, numbering is the main thing, but let us check that how the number that we could get. Suppose if I number it from this end, so therefore this one would be carbon number 1, this one would be the carbon number 2, and yes, here we could receive the first multiple bond, that is the carbon-carbon double bond. So I would name it over here as 2, suppose, because we have to also check whether the triple bond and double bond, they are equidistant or not. So this is the carbon number 2, carbon number 3, 4, and again 4 we get a carbon-carbon double bond, 4. This is 5, 6, and on 6 we get carbon-carbon triple bond, 7 and 8. So this is what we have got it from left to right, if what we have chosen. But what we have did a numbering from right to left. So that is, if this is carbon number 1 and at carbon number 2 I could get a carbon-carbon triple bond, or we could say it's carbon-carbon multiple bond. Then this would be the third one. Then again it would be fourth. So this one would be the fourth, and that is this one would be fourth, fifth, sixth. Again I am getting the number 6, 7, and then again 8. So I am getting the same number, that is 2, 4, 6 from both the end to the multiple bonds. But which one would be the prior one? That is, I could either number it from here or either number it from here. But the rule of IUPAC nomenclature of alkyne, it said that even the carbon-carbon double bond and suppose the carbon-carbon triple bond are equidistant from both the end, then we should number it from that end where the carbon-carbon double bond starts. And that is the reason we will number it from this side. So therefore, this one would be the first, second, third, fourth, fifth, sixth, seventh, and eighth. So this is the numbering. So that is the reason that the IUPAC nomenclature is very essential for us to understand. The rules of IUPAC is very essential for us to understand. And now we could name it, and we could see that the carbon-carbon double bond are the one, because it is basically an enine, and we could see that the carbon-carbon double bond is at carbon number 2, then carbon number 4. So basically we have to mention this names or this alkenes or enes earlier, and then we could move on to the basically parent alkyne. So therefore the double bond starts from carbon number 2 and carbon number 4. So therefore the total number of carbon that is been present over here is basically 8, basically known as an octane in terms of an alkane. But this is not an octane, or this is not an alkane, this is an enine. So making this to be called as oct, and basically there are 2 carbon-carbon double bonds over here, so therefore we could name it as octa. That is, here we could see that is the carbon-carbon double bond starts from carbon number 2, then carbon number 4. So therefore the name is octa 2, 4, di, ene, and on the 6th carbon atom we could see carbon-carbon triple bond, naming this to be called as 6I. So So this is the IUPAC nomenclature of the that is alkyne that we have. So this is what we have did. So thank you friends for watching this video. I hope you understood this video very clearly and you share this video with your friends. And yes, don't forget to subscribe to Ekeeda channel. Thank you so much.